DI Khan, and they got contaminations from the flood, and more or less they are open, so they are more likely that they have fecal coliforms and other contaminations. These communities of outskirts of DI Khan have, before flood and after flood, these open sources for drinking water. So they have, at community levels, they have large ponds, and they have household level, and they are using water from this. The conditions of these water sources is that animals are drinking water from them, and they have contaminations, they are open, rainwater is entering to them, and all types of contaminations are there. So these waters are not fit for drinking, and they have the microbiological contaminations and physical contaminations as well. These are the feed channels which feeds these open ponds. These are the irrigation channels, because these people have to collect the irrigation water for their drinking purpose and to collect the rainwater for the drinking. This is the overall background of all the conditions of these ponds. So we have to take some step to make it fit for drinking and to enhance its quality. During the presentation, we will talk about filtration. So I want you that you will get an idea of what is basically filtration. Filtration is basically the separation of solid from the liquids. So basically, it water passes, liquid passes from media, sand, and get suspended solids get separated. So this is one of the treatment process in water treatment. So filtration is one of the process. Filtration has a basic, in the single medium filtration we have the sand bed, and these run under the action of gravity. Water stands on 4 to 3 feet above the sand bed and passes through the sand bed and through the gravel spot to the under drain system and collected. So one of you will be thinking about how a sand bed can basically clean water. So these are the 4 mechanisms, actions taking place. This is one is the adhesion, flocculation, sedimentation, and straining. So what happens when water passes from the sand bed? The flocks are in contact with the sand particle, so they adhere. वो उनसे चिपक जाते हैं, तो they can get clean. And when these pore size is very small, so the suspended particles has to pass through a very narrow channel, so they get contact with each other, so large particles become formed and flocks are formed. And the other thing is that when these large flocks are formed, so these settle down, their velocity is dead, so they settle down, and at the end the particles are already removed, so new particles come, the straining action become in action, so the suspended solids. Basically it's the surface removal and in-depth removal. Surface removal at the top of the sand bed, and depth removal is in the bed itself. So, and we have the pore volume, much of the pore volume in the bed, so to store the suspended solids. After some of the time when this filtration runs for some weeks, the biolayer formed automatically at the top of the surface. So then it acts as a biosand filter. And when the biolayer forms, the bacterial removal efficiency of this sand filters increases. As we have the biolayer forms in second and third compartment of our design. The turbidity removal efficiency range from 90 to 98%, depending upon the feed water turbidity, which is feeding to these water filtration galleries. It also helpful in removing the irons and manganese. And for removal efficiency of arsenic, because DA1 is highly contaminated and they have these arsenic survey of the area, so some of the expertise of Sajjad Khan, Zulfi Bhai and Nisar will be helpful in this. Bacterial removal efficiency of after the formation of the biolayer is 92 to 96% when the biolayer forms. It's 100% good in parasite removal, and it also helps to improve the taste and odor. Basically, I have given to you the theory how slow sand filters works. So I give you a graphical representation of how basically the inside working of the yes sir. So basically we have designed these water filtration systems for the 3 communities of the area, and for your understanding I am now going to represent some of the calculations we have done, basically because it's not the just that we have done. Just I am giving you a bit of the considerations. We have counted the population of the area and the water consumption of this population, and we have projected this for the 10 years by period, and we have considered the domestic needs of the population. The data we have collected from the field, these are the samples. You can see that if you compare it the NTU comparison scale, it lies around between 100 to 80 NTU. This is some of the other calculations that I have shown you. We have considered the population and water consumption demand. On the basis of these are the filtration area, surface area we have calculated, and on that basis we have projected it reverse, that what is the filtration rate at 1 minute and 1 hour. It will be is it sufficient for the community or not? These are the basic drawings of the filtration. This is the open source, as I have told you. This is the intake structure which is in the pond. It's and these are the connecting pipes. This is the first filtration compartment. Water passes through this filter medium. Then this is the second filtration compartment, and then water goes through this third filtration compartment and to this hand pump. So basically, we have designed in such a way that community need no pumping of electricity or external pumping. So we have installed a hand pump so that community can take the water easily, and no outside intake to this filtered water from outside. This is some of the other calculations of these 3 compartments, the depth calculations on the basis of what we have done. This is the second compartment. This is the third compartment. What the material specifications and quantity we have used. So just to share you some of the things, that the muslin cloth membrane is used as a diffuser layer, and then the sand bed. This is the thickness of the sand bed, and this is in the first compartment. I should mention this is the effective size uniformity coefficient, and the gravel sport under the bed, sand bed which has the sport, the sand bed which consists of the 2 layers. This is the top layer and this is the bottom layer. These are the thicknesses of these 2 layers, gravel sport, and the nominal sizes, which is because as I have shown you that this is 3/8 down. So this lies in between this range in mm. So this is the total thickness of the gravel sport which is supporting this sand bed. The rest of the next columns are the quantity calculations. This is the same. For the second compartment, the gravel spot is the same, but the thickness of the bed is changed according as per the calculations. This is the third compartment. As I have shown you that we have designed an intake structure in the pond to collect the water, to meet the water requirements of the community. So we have to design this intake chamber. This is the surface area we have calculated, and this is the depth. We have designed this intake structure as a first level screening in the pond to remove the leaves, particles and other large flocks. This is just to give you a glimpse of the materials we have used for replication in any of the other area. These materials are low cost, available at the local market and cost effective. And these can be utilized as per the systematic layers, so it works. Like you have to put the oil in the engine and water in the, so the engine works in cars. This is some of the more calculations of the basis of which we have designed this. This is the hydraulics of filtration involved. These are some of the factors we have taken into consideration as per the site area. These are some of the 4 formulas involved back, the engineering formulas: viscosity, Reynolds number, drag coefficient, bed factor, and then we have to calculate this head loss in each of the sand bed where the water passes. On the basis of these hydraulics of filtration, we have calculated this pressure head loss at different points of the filtration: the reservoir, intake chamber, inlet, and then the inlet of first compartment, inlet of second compartment, third compartment, and finally at the inlet of hand pump well. On the basis of volume filtrate, which it does over the number of periods of days, so these are some of the projections of the filtered water by the filtration and head loss versus head loss. This is the effluent turbidity. As the effluent turbidity increases, so the head loss vice versa increases as the feed water. Now I have shown you the office work what we have done, and now comes to the implementation at the ground level. So there's nothing that you have to calculate and not implementing at the site. So we have to take the depths, because these structures have to be underground, so we have to be precise, as well as to taking the levels in the pond's depth maximum, and for the accurate calculations of excavation, we have to make the trenches. Then we made the layouts on the ground, and we have started the manual excavation where possible to involve the local community. We have involved the local community at each step of these construction activities. These are some of the more we have to face some of the challenges that it was a fast track activity, so we involved the machinery for more deep excavation and to speed up the work at where necessary, and where we are stuck with the hard strata at the ground. So when these trenches will be ready for the masonry work, then the masonry work we have started from the filtration galleries, first compartment, second compartment, and the hand pumps. Then finishing of these filtration galleries and intake chamber and connecting them to one part to the other, and pump installation at the hand pump well. These are placing of filter material in the 3 compartments at the layer-wise. This is the cut-off wall we have constructed in between at the end of the intake chamber. This is the water intake structure to collect the water from the pond and transport it to the inlet of the first compartment of the filtration gallery. These are some of the pictures of completed filtration structures. We have involved the community to inaugurate these water filtration systems, so they are keen and giving sense they are owning these filtration systems, and this is first time in their history. So we have get involved to open at the pond and then at the pump. And when the first time water approaches these filtrations, so you can see the affluent turbidity in the coming to these. Community is totally involved for the construction of these filtrations, and they are involved in each and every steps of these water filtration galleries, so that operation and maintenance will be easy for them to understand. Water samples we have collected at the final stage of hand pumps, and we have calculated the turbidity. You can clearly see that the turbidity lies between the 10 NTU to 5 NTU. This is what we have made the difference in change. Now you can see the water at the pond we have collected, and this is the Nestle mineral water, and this is the water from our filtration tank. So this is the difference we have basically created, starting from the open sources which are more contaminated, and improving its quality for drinking purpose to that level. Thank you very much.